Hello, now we're going to solve problem 3.2.7.1, school spending per student. In 2010, the average per student spending in the school districts in Los Angeles County was $8,228, with the population standard deviation of $977. If we know the spending per student is normally distributed, what is the probability the school district spent over $10,015 per student, the amount spent by the Los Angeles Unified School District for that year? So by knowing the data is normally distributed, we can find some interesting results with only being given three numbers. When I do these types of problems, I do parts of them in Excel and parts of it by hand. I like to draw the normal curve as a diagram, which is difficult to do in Excel. So I'll switch screens and go to the pad. I would also like to just do this on paper, but it's hard to show via video. Let's start by drawing a generic normal curve. There are several things to remember about the normal curve. The area under the normal curve is 1. It is symmetric, and the center of the normal curve is the mean. So here's our mean. School spending per student with a value of 8,228. The curve has a standard deviation of 977, which tells us how wide the curve is. However, we do not hand draw these curves to scale, so it won't change our hand drawing. We want to find the probability of drawing a school district that is higher than 10,015. The value of LAUSD. The 10,015 value needs to be to the right of the mean value of 8,228. We were guessing how far to the right. The graph, even if not to scale, will still be helpful. We're first solve this problem by hand. Then we'll look at tools in Excel that are faster, but not always as intuitive. In this problem, we want to find the area of the right above 10,015. This area is the probability the school district spends more than LAUSD. To be able to use the normal standard distribution table, I need to convert my data into a z-score. The formula to calculate a z-score is equal to x minus mu over sigma. The value of x is 10,015. The value of mu is 8,228. The value for sigma is 977. You can calculate this with a calculator or an Excel. Let's quickly calculate it in Excel. I'm going to stop share and then go back to our Excel spreadsheet. In Excel, I'll put x equals 10,015, mu equals 8,228, sigma equals 977. Because it is inconvenient to get the Greek letters, we will just spell them. Now to calculate the z-score. Put equals, open parenthesis, x minus mu, close parenthesis, divided by sigma, the 977 value. Rounding the result to 2 digits give us the value of z equals 1.83. Let's switch screens and go back to the pad. Now that we know what the z value is, we can plot the z-values that we know. The z-score associated with 10,015 is 1.83. The z-score associated with the mean is 0. The mean always has a z-score of 0 because the formula is x minus mu in the numerator, and that equals 0. Okay, now we want to find the area to the right of z equals 1.83. First, we'll look at the standard normal distribution table, and then we'll look at some formulas in Excel to solve it. Let's switch screens to see the standard normal distribution table. The standard normal distribution table will give us the area to the left of any z-score. The graph at the right reminds us that we are given the area to the left. We want to find 1.83. So scroll down to find 1.8, which is row 54. The first column is 1.80. The second column is 1.81. The third column is 1.82. And the fourth column is 1.83. We get a value of 0.9664. So the area to the left of z equals 1.83 is 0.9664. Now I'm going to stop sharing and go back to the pad. So 0.9664 is the area to the left of z equals 1.83. But because the area under the normal distribution curve is 1, the area to the right of z equals 1.83 is equal to 1 minus 0.9664, which equals 0.0336. So there is a 3.4% probability that you'll randomly draw a school district in LA County that spends more than LAUSD. I prefer making these diagrams and solving this type of problem. However, we have tools in Excel to make it faster. Let's go back to our Excel sheet. We will write it more formally because we cannot show it on the graph. Then we'll use Excel formulas to solve it. So more formally, we are trying to find the probability that X is greater than 10,015. However, if I want to use the standard normal distribution table, I need to convert that into P probability that Z is greater than 1.83. The table and the Excel formulas do not give us the area to the right, the greater than, but the area to the left, less than. But the total area under the curve is 1. So the area to the right is equal to 1 minus the area to the left, or for this problem, 1 minus P, the probability that Z is less than 1.83. We can find P probability that Z is less than 1.83 by looking at the standard normal distribution table, or we can start using Excel formulas. There are two formulas. The first is norm.s.dist, which has you enter the z-score. So put equals norm.s.dist, open parenthesis, type in 1.83, comma, true. The 1.3 is our z-score, and the true means we want the area to the left of that score. False means that we want the y value of the curve at that z-score. I don't think you will ever use it. This gives us an answer that rounds to the fourth digit for the value we have in the table, 0.9664. Alternatively, you can use norm.s.dist, open parenthesis, then click on B9, put a comma, type true, close parenthesis, and you will get a more exact number because the z-score is not being rounded. Then you get 0.9663. Finally, if you don't want to calculate the z-score, you can use norm.dist. Norm.dist asks for the x value, the mean, mu, the standard deviation, rho, sigma, and then true or false. Norm.dist just asks for the information to internally calculate the z-score and then gives the same answer as norm.s.dist. So enter equals norm.dist, open parenthesis, then click on B5, put a comma, click on B6, put a comma, and then click on B7, put a comma, then type true, close parenthesis. The value Excel calculates is the same at 0.9663. To get the final answer, calculate equals 1 minus, and click on the cell with the area to the left to get 0.337. So the answer to the probability that we'd randomly choose a school district that spends over 10,015 is about 3.4%. That is the answer to 3.2.7.1.